For objective 3, we are calculating with kinetic energy. Using kinetic energy, we're going to have the formula where kinetic energy equals 1/2 mass times velocity squared. Let's take a look at number 1. It says a 3-kilogram bowling ball is traveling at 2 meters per second. What would its kinetic energy be? Show your work. Kinetic energy, I'll start by showing my work, starting with the formula. Mass equals, or 1/2 mass times velocity squared. Now, in this case, our mass is 3 kilograms. Our velocity is 2 meters per second, but we're going to square that number. Again, using order of operations, we'll start with the squared. When we square 2 times 2, that's 4. Then we multiply that times 3. That would make 12, but then we take half that, so our answer is going to be in 6 joules. For question number 2, a boat traveling at 5 meters per second. It has a mass of 600 kilograms. Mass of 600 kilograms. How much kinetic energy does the boat have? Show your work. Or kinetic energy, it's going to be 1/2 mass times velocity squared, where our mass is 600 kilograms, our velocity is 5 meters per second, and we're going to square that value. We'll start by, again, order of operations. We'll start by squaring our velocity. 5 times 5, that's, of course, 25. We'll multiply that times 600. 25 times 600 is going to give me 15,000, but I want to take half that, so we're going to divide that by 2. And so we end up with an answer of 7,500 joules. 7,500 joules. Number 3 says Jeremy is trying to knock over a bottle at a carnival with a small beanbag. The beanbag doesn't have enough energy to knock over the bottle. The original beanbag had a mass of 4 kilograms, and he threw it with a velocity of 4 meters per second. Option A is to double the mass of the beanbag and throw it at the same speed. Option B is to keep the beanbag the same, but throw it twice as fast. Which option, A or B, will cause the most significant increase in kinetic energy? Use a complete sentence to explain your answer. Well, since we know the formula for kinetic energy has us squaring the velocity, we know that an increase in velocity is going to have a greater impact. So, we could go ahead and say, since the formula has the velocity squared, okay, that's the V2, an increase in velocity will result in the largest increase in kinetic energy. Now, letter B says complete the work for both situations and show that option A or option B would cause the most significant increase in kinetic energy. So we're going to go ahead and show the math for both of them. We're going to show the math for option A and then, of course, again for option B. For option A, kinetic energy is 1/2 the mass. So we've doubled the mass, so now it's up to 8 times the velocity. It's still at 4, but that velocity is going to be squared. When we do that math, we end up with a total kinetic energy of 64 joules. Now for option B, our kinetic energy is 1/2 the mass. In this case, our mass remains 4, which is what we started with, but our velocity instead of 4 is now 8, and that will be squared. We square the velocity, multiply it times 4, divide by 2, gives us 128 joules. So mathematically, we see that we have a greater increase in kinetic energy from greater velocity.